Hello guys, in today's video we will solve some numericals related to the BOD. So BOD is nothing but biochemical oxygen demand. Usually some oxygen is always dissolved in water, which is called dissolved oxygen. Okay, and DO is very necessary for the survival of aquatic life, and a minimum of 4 ppm of DO is required for the survival of the aquatic life or marine life. So in case of wastewater, the organic matter requires the dissolved oxygen to decompose them. The microorganisms that decompose the organic matter in the presence of oxygen, they are known as aerobic bacteria, and the aerobic bacteria basically requires the microorganisms to oxidize the biodegradable organic matter. Now we can further classify the organic matter into two types. The first of all is the carbonaceous matter, which is the first stage BOD, and the nitrogenous matter, which is the second stage BOD. And how to find out BOD? So BOD, for finding out the BOD, we have a lot of methodology. Here you saw in my videos how to find out the BOD. So BOD in 5 days will be 60 to 70% of the organic matter, which is decomposed. In 20 days, which will be 95 to 99% of the organic matter is oxidized. Water sample is diluted and aerated, and the initial DO is found, then incubated for 5 days at room temperature at 20 degrees C. After 5 days, we find out the DO final. BOD5 is equal to DO initial minus of DO final into the dilution factor. And dilution factor is the ratio of volume of the diluted sample to the volume of the undiluted sample. So the dilution factor would be diluted sample on the undiluted sample. Now we have here very important thing, which is how to derive the BOD equation. Here this is the BOD curve. Now this is the time t. Now this is the organic matter present in the water. This is L naught, which is the maximum point here, and let's suppose this is LT, and this is time. LT is the BOD remaining, and DL T versus dt is directly proportional to LT, and LT is equal to L naught into A power minus K into T. So the BOD consumed would be YT is equal to L naught minus of LT. Now YT is equal to L naught minus L naught into E to power minus of KT. YT is equal to L naught if we take common terms here, so it would be 1 minus power of KT. This is in power form. If we intend to convert into another form, so it would be L naught into 10 to the power minus of KT. So this K dash is equal to K upon 2.303. And also the K factor, which is also known as deoxygenation constant, here K at any time t would be equal to K dash at 20 degree. So this is at 20 degree into 1.047 power, this is into t minus 20. And here L naught is basically the ultimate BOD, or you can also say this as maximum point, and this is the BOD at any time t. Now these were all the theories about the BOD. Now let us solve a numerical related to 2 or 3 numericals related to the finding of the BOD. Now there is one example here in which we have 30 milliliter concentration of the sample we have diluted in 300 ml of the BOD bottle. So the initial DO here is 8.5 and DO final is 6. So BOD in milligrams per liter would be equal to 8.5 minus of 6 into 300 upon the sample volume. This is my, up to which it was diluted, and this is my real sample volume. It is equal to 25 milligrams per liter, which is the BOD. This is estimated at 87% of the BOD, and the COD of the, which is another term of the, we call as chemical oxygen demand. The wastewater is around 300 milligrams per liter, and this is considered as a first order reaction where the K is equal to, okay, we'll use a natural dog, and the coefficient of theta is equal to 1.47. Here we have to find out the BOD value in milligram up to 1 decimal after 3 days of the incubation. So we have to find out the BOD 3. Now as you saw the formula here, where we have L naught LT. LT, as I told you, this is the L naught is the ultimate BOD, and this is the BOD at any time. We'll use the concept of this one. First of all, we have to find out the L naught, which is the BOD ultimate, which is equal to 0.87 into COD, which is equal to, and COD here is around 300, so it is 261 milligrams per liter, and K is given as 0.23, it was, and per day, this is the deoxygenation constant, and theta here is 1.047. And also there is no information here about the temperature, so we'll use the rate constant as the same. So the K27 here would be K at 27 degrees C. It's not at after 27 days, so it is equal to 0.23 into 1.047, 27 minus or 20, which is equal to 0.317. So BOD at 27 degrees C is equal to L naught into 1 minus E KT. Okay, this is equal to 261. Okay, and if we convert this into form of 10 base, so it would be 10.317. We already calculated K, and this is, we have to find out after 3 days, so it is equal to 160.2 milligrams per liter. Now there is another problem in which we have a wastewater, and here the ultimate BOD, which is L naught, is 280 milligrams per liter, and BOD at 5th day is equal to 240 milligrams per liter. So we have to find out the 28th BOD. So for this one we will use the same formula, which is equal to, so T here is 20. Okay, first of all we will calculate the K, which is the deoxygenation constant. So Y5 is equal to L naught, and this is equal to, okay. Now we know that BOD 5 is 240, and this is equal to L naught, and the ultimate BOD is 280, so it would be K into 5. So from here the K is come out to be 0.390 inverse, and then we will substitute here to the first equation. Okay, then it would be BOD 20 is equal to, which is Y20 is equal to L naught to 1 minus K into 20, and K we already find it out, so it would be, okay, 279.9. Okay, this is our last question for today. So we have a very simple question where the BOD, we have to find out the 5th day BOD. So we have a sample of 15 ml, which is diluted to 300 ml, and the initial DO is 8, and it has reduced to 2. Okay, so we have to find out the 5th day, so we have to find out the BOD. So it would be DO initial, which is 8, 2 upon the, and it has, the dilution ratio, we'll find it out by 15 by 300. So this was all about BOD numericals. You can more and more numericals. So there is one more simple numerical, let us discuss that also. So we have a BOD 5 of a wastewater, which is equal to, so guys, in this numerical we have to find out the BOD 8. So BOD 5 is given here is 150 ppm, milligrams per liter, which is at 20 degrees C, and K value is 0.23, so which this is at 20 degrees C. So we have to find out BOD 8, okay, if the tests were run at 15 degrees C. So for these kind of questions, so this is YU, which is ultimate BOD, which is equal to Y5 upon this one. So here this Y5 is already given 150, so it would be 220 milligrams per liter ultimate BOD. And we also have to find out the K value at 15 degrees C, which is equal to KT is equal to K at any temperature, which is here 20. So K at 15 degrees C will be, we already know this value, and which is equal to 1.47 into 15 minus, which is equal to 0.18. Now for finding out the Y8 BOD8 is equal to 220 into 1 minus E 0.18, and from here we got 8, sorry, 0.18, and this is an 8, so it will be 168 ppm. So this was all about simple numericals. There are more and more numerical related to the BOD, also related to the, I mean, if you get a curve, and also don't forget to like and subscribe. This was all about the BOD numericals.